Now, sometimes we have equations that are called special cases. And what are special cases? Special cases are equations that either have no solution or an infinite number of solutions. So let's look at no solution first. When you solve an equation with variables on both sides and you eliminate the variables completely, leaving an untrue statement, the equation has no solutions. So this example's been done for you. This over here has been distributed, so you end up with 8x plus 10. These 8x's disappear because when you go to move one from the one side to the other, they're identical, they disappear. Negative 6 is equal to 10. And negative 6, of course, does not equal 10, so therefore there are no solutions to this equation. You would not write the answer as being 0 because that's saying the solution is 0. If you have an equation and this happens, you have to explicitly state no solution. You have to write that or select that from multiple choice or multi-select. So when you have an equation with variables on both sides and you eliminate the variables completely, leaving a true statement, then that equation has infinite number of solutions. So here's another example. Once again, this has been distributed. You can tell right here, these are identical. So that's going to be your sign, because what happens is when this disappears, you end up with negative 6 equals negative 6. And negative 6 does equal negative 6. So you would say that there are infinite solutions to this equation. And that would be your actual answer. You would write infinite solutions. Let's look down here at the practice. So we're going to distribute our negative 3. Over here we have negative 18n minus 25. And then negative 3 times negative 6, you end up with negative 18. Negative 3 times 6n is negative 18n. So my variables here are identical. So if I'm just going to cross those out. If they're identical, you know they're going to cancel each other out. What we're left with is negative 25 is equal to negative 18. This is not true, so our number of solutions, none, or no solutions. This example over here, once again we distribute. Negative 4 minus 32x is equal to 50 minus 5x. My variables are not the same here, so I know that this is going to actually have a solution. So I will add my 5x to each side. Negative 4 minus 27x equals 50. I'm going to get rid of my 4 by adding it. Negative 27x is equal to 54. Divide by negative 27. X is equal to negative 2. So how many solutions are here? 1. There is only one solution to this equation. Coming down here, let's distribute. We have to distribute on both sides. Negative 9r plus 63 is equal to negative 9r minus 18 plus 4. I need to combine right here. Negative 9r plus 63 equals negative 9r minus 14. My variables are the same, so I'm going to cross them out. 63 equals negative 14 is what I'm left with. That is not true, so there are no solutions. And that means there is not a single number that can be substituted in this equation for r that will make a true statement. Last example, we're going to distribute our negative 9 right here, so we have 7p minus 9p plus 45 equals 45 minus 2p. Combine like terms right here. Negative 2p plus 45 equals 45 minus 2p. My variables are the same, so I get rid of them. I'm left with 45 being equal to 45, which is true. So there are an infinite number of solutions to this equation. And that means any number that you substitute for p will result in a true statement. So whether you substitute negative 1, 500, 3/4, any number you substitute will make this a true statement. So that is how you identify the number of solutions to equations.